we go, okay, well, it's great that we looked at the ground reaction force peaks, but we also have the loading rate, right? So a loading rate, not only we want to generate force, but how quickly can you generate force? So again, in this healthy controls only so far, because we couldn't get ACL individuals in there, we had people walk at symmetrically at 0.75, 1, and 1.5. And what we found was that there was somewhat of a linear relationship between these two these two metrics. And so it's something that we haven't really seen before. And so it was great to see that, as you, we like this, that this linear relationship held across different speeds because, we didn't want to say your ratio needs to be this for 0.75 and this for 1. We saw that these linear relationships held across different walking speeds. And so then we said, we took our healthy controls and we said, let's apply this perturbation. We applied the 0.5 perturbation. And what we started to see is that they all actually resided outside of this region, or for the most part, resided outside of this region, right? So for us, it kind of was a supportive of this metric in that, if you're healthy, you're going to have this linear relationship between your peak force and your loading rate. But if you're exhibiting some kind of abnormal neuromuscular deficiencies or physical impairments, you're going to reside outside of this region. So that was a really exciting finding for us, and it validated, supported this work. And so we wanted to figure out, okay, great, we have this linear relationship, but what does this metric really tell us about anything? And what we think it's looking at is motor control. So motor control is a regulation of movement. And so you need force and the rate of force to regulate movement. So we think this is a nice motor control metric. Again, the healthy individuals, it further supported and validated that this asymmetric walking was a physical perturbation and a physical impairment in at least healthy individuals. And then we thought about, well, if we kind of expand on this work as we get more populations in here, if we get PFP or things of that nature, can we kind of make it similar to the body mass index where we start to figure out as you stride away from this, are you going to be at greater or more risk? If we think about return to sport metrics, if you're only a little bit out, does it mean that you can return to sport, but you can't do contact injuries? But if you're further out, you go, no, you can't go back to sport. You need to get more rehabilitation. So that's kind of our future goal of this. So that was really exciting. But then what was even more exciting is said, well, we've only been doing this in healthy individuals. And so we're like, well, it's great. It works in healthy, but how does it work in ACL individuals? So we were fortunate to work with our collaborators, Dr. Noren, and we got some ACL people running. And these are individuals who had reconstruction surgery about 6 months prior, and they'd all been returned back to sport, right? So they all been told that they are ready to go back to sport. And we noticed that we looked at the peak force versus loading rate again in running. We saw that there was a strong correlation between those. When we looked at the non-reconstructed limb, we saw that the correlation was still there. But however, when we looked at this ACL reconstructed, we found that these people were not exhibiting this linear diagnostic. So again, when we thought back to what we saw previously in the healthy controls, is that individuals who have this, healthy individuals have this linear relationship. And then when we kind of disrupt and have a physical impairment, this kind of falls apart, which was great. And I always feel bad saying it's great because these people are injured. So I'm not happy that they're injured, but I am happy that these metrics are picking up these differences.
Your leg is quantifiably messed up.
Exactly.
Yeah.
It really is. So, and I think, and it's one of these things, like I said, these people were all cleared to return to sport. And then very quickly, we were able to say, no, you're not. I mean, this is based off of 10 seconds worth of running data. So we think, the challenge is if you go to a doctor's office, they're not going to have this instrumented treadmill in their office to measure some of these metrics. So, one of the things we're trying to figure out is, hey, we have these quantifiable metrics, like you're saying. Can we figure out ways to put them in foot sensors and other ways to quickly measure these things? So I think this was just the summary of that. But like I said, despite extensive rehabilitation, these injuries persist.